Hello. Yes, let's start. So the next periodic trend or periodic property that we're going to do, people, is called as electronegativity. So what is electronegativity? Please define EN. Yeah, electronegativity for me. It is the tendency of an atom to attract shared pair of electrons towards itself in a, now ये important है people, in a covalently bonded molecule, covalently bonded compound, कुछ भी बोलो. Now let us understand this, इसका मतलब क्या है. So let us assume that people, we have a bond between, let's say like hydrogen and fluorine. ऐसा एक HF bond है. It's a single covalent bond. A single bond मतलब there are two electrons. So usually हम ऐसे बनाते हैं या 10th standard पे कुछ ऐसे बनाते हैं आप लोग, like something like this, ऐसा. Yes or no? ठीक है. But what really happens here is, वो जो electron pair होता है ना, it is not exactly in the middle of the two atoms. It is more towards fluorine. तो जो इलेक्ट्रॉन डेंसिटी है या आपका जो इलेक्ट्रॉन क्लाउड होगा ना, वो फ्लोरीन के नजदीक ज्यादा होगा compared to hydrogen. I'm not making all the electrons, I'm just making the covalent bond वाले electrons. So electrons are closer to fluorine rather than hydrogen. And why are they closer to fluorine? Because fluorine की pulling tendency to pull that shared pair of electron towards itself is greater. इसी tendency को हम क्या बोलते हैं people? EN or electronegativity. ठीक है. Now what happens because of this? Electrons are closer to fluorine. It develops what is called as a partial negative charge. ठीक है. How will we read this? इसको हम क्या बोलेंगे people? Partial negative charge. ठीक है. And equal in magnitude but opposite in sign. Hydrogen will develop a partial positive charge. Anyone who did not get this? I repeat, fluorine क्या produce करता है? Partial negative charge. And charge का magnitude same but negative की जगह अब positive. Same magnitude but positive charge is developed on the hydrogen atom. We'll call that as partial positive charge. Anyone who did not get that till here? Now look at this. Though we will study this more in detail. HF, there is a covalent bond between hydrogen and fluorine, but they are still developing charge. इसको हम आगे जाके पढ़ेंगे as ionic nature of a covalent bond. See, हमने अभी तक कहाँ पढ़े? Where are charges developed? In ionic bonds. Like sodium will donate one electron, chlorine accepts one, तो sodium पे plus आया, chlorine पे negative आया. तो we say the charges are developed in ionic bonds, not in covalent bonds. But ऐसा नहीं है. Even covalent bond can develop charge. इसको हम बोलते हैं ionic character of covalent bond, and vice versa. Ionic bonds also have covalent character. We will study that eventually in future chapters. Now such a bond where partial positive, partial negative charge they are developed, this is called as a polar bond. I repeat, in any bond where there is a partial positive charge developed, there is a partial negative charge developed, then such a bond is called as a polar bond. With me till here? And ये polar bond or polarity is generally developed due to difference in electronegativity. ये क्यों होता है? Because of difference in Did you will get that? जहाँ पे भी there is a large difference in electronegativity, वो polarity उतनी ज़्यादा होती है. I repeat, greater the difference in electronegativity, greater will be the bond polarity. Anyone who don't get that? With me till here? Sure. Now, there are various methods to measure electronegativity. And the first method to measure electronegativity is called as Pauling scale. ठीक है? Just like electron affinity हमने measure किया था या electron gain enthalpy measure किया था in terms of kilojoules, kilocalories, electron volts के term में. Just like ionization enthalpy was measured in terms of heat or in terms of energy, electronegativity measure करने के लिए एक unit बनाया गया and that was given by Pauling, जिसको हम बोलते हैं Pauling scale. ठीक है? Now, पहले Pauling scale का formula लिखते हैं. Pauling gave a formula to measure electronegativity. He said that let's say there's a bond between A and B. So according to Pauling scale, the difference in the electronegativity of AB, this difference in electronegativity of AB is equal to bond dissociation energy. I'll write the full form iska. The bond dissociation energy of AB minus under root of bond dissociation energy of AA into bond dissociation energy of AB, and the difference in electronegativity delta E of AB is given by 23.08 into electronegativity of A minus electronegativity of B, the whole square. Or the entire formula can be written as together 23.08 XA minus XB is equal to this quantity. If I take, sorry, this is squared. I can take 23.08 to the right, तो वो बन जाता है XA minus XB the whole square is equal to this entire quantity divided by 23.08, and if I take square root, so XA minus XB is 0.2 into under root of bond enthalpy of AB into bond enthalpy of AA, sorry into नहीं यहाँ पे minus bond enthalpy of BB. This is the formula that you have to remember. तो ये पार्ट नहीं आएगा तो भी चलेगा, but you can just memorize this formula. Now let's understand इसमें एक एक quantity का मतलब क्या है. What does each and every variable that you see over here, what does that mean? XA is the electronegativity of A. XB is the electronegativity of B. Here we have assumed that A is more electronegative than B. AB इसका मतलब क्या होता है? Bond dissociation enthalpy. It simply means अगर आपके पास एक bond है between A and B, the amount of energy required to break this bond is called as bond dissociation enthalpy. A और B के बीच के bond को break करने के लिए जो energy चाहिए, that is called as bond dissociation enthalpy. Similarly, BEAA will mean bond dissociation enthalpy to break the bond between A and A, and BBB will mean to break the bond enthalpy between B and B. Did you people get that? ठीक है. Now, when you substitute values in these, what we get is, and he also arbitrarily gave fluorine the highest electronegativity value. Fluorine is the most electronegative element in the periodic table. I repeat, it is the most electronegative element in the periodic table, और उसका Pauling scale value is 4. Now you may not remember the values, it's okay. Value आपको याद रखना जरूरी नहीं है. But in the periodic table, the most electronegative element is fluorine, followed by oxygen, then followed by nitrogen, then we have chlorine, then we have bromine. ठीक है. So 1 2 3 first 4 elements याद रख जाएंगे in terms of electronegativity, so that is also fine. ठीक है. And the most electropositive element, non-radioactive, is cesium. Cesium को आप बोल सकते हो this is the most electropositive element in the periodic table, or you can say it's the least electronegative element in the periodic table. With me till here? Chalo, jaldi copy this for me. Now, so after Pauling scale, the next scale to measure electronegativity is given by Mulliken, and we call it as the Mulliken scale. Now, according to Mulliken scale, electronegativity, I'll write that as En. Okay? Wherever I write En, that means electronegativity is equal to electron affinity plus ionization potential the whole upon ओके, या इसको हम ऐसे लिख सकते हैं, शॉर्ट फॉर्म में लिखा तो इलेक्ट्रॉन एफिनिटी प्लस आयनाइजेशन पोटेंशियल अपॉन 2. Now people, what is the basic difference between electron affinity, electron gain enthalpy and electronegativity? In electron affinity or electron gain enthalpy, actually electron gain किया है, we've added an electron, but electronegativity में क्या हुआ है, the electron cloud or the shared pair of electron is near the more electronegative atom. तो वो हमें difference समझना है. Now Mulliken scale, now similar to Mulliken scale, we can also write Pauling scale in terms of the form of electron affinity and ionization potential. So Pauling scale का एक और फॉर्मूला हम लिख सकते हैं, the electronegativity value according to Pauling scale can also be written as electron affinity plus ionization potential upon 5.6. Just remember both the formulas. Next. Chalo. Now if I want to write the general trend for electronegativity, can someone tell me what do you think is the general trend for electronegativity? Period from left to right in a period from left to right. What do you think people happens to electronegativity? Will it increase or will it decrease? Electronegativity increases. How do you think electronegativity increases? Because what increases? Effective nuclear charge increases. What happens to size, people? Size decreases. Similarly, if I want to know the general trend in a group from top to bottom, क्या लिखेंगे हम? What do you think happens to electronegativity? Electronegativity decreases. Why? Because effective nuclear charge and size increase. See, if we see, there are no exceptions in any general trend of electronegativity. जितने हमने बाकी के periodic properties में we've learned so many exceptions. There are no such exception here in electronegativity. But how electronegativity affects different properties, we need to understand that. Now, let's say I have certain oxy acids of chlorine. Oxy acids means acids containing oxygens. ठीक है, इनको हम क्या बोलते हैं people? We call these as oxy acids of chlorine. Now, the charge on oxygen is -2. Charge on hydrogen is +1. So -2 and +1. What is the charge on chlorine? +1. Overall 0 होना चाहिए. So I repeat, oxygen पे -2, hydrogen is +1. So -2 + 1 is -1. 0 करने के लिए chlorine पे it is +1. All these are called as oxidation numbers. We'll do these in detail when we do redox reactions. There's a chapter called as redox. Similarly over here, oxygen पे charge कितना है? -2. So there are 2 atoms of oxygen. So what will the total charge be? -4. Charge on hydrogen कितना है, people? +1. So what is the charge on chlorine over here? +3. Anyone who did not get that? Over here, charge on oxygen is -2. So total charge on oxygen -6, हाइड्रोजन पे +1. So कोई बताएगा what will the charge on chlorine be? +5. And similarly यहाँ पे can someone tell me what will the charge on chlorine be? +7. Okay, these are called as oxidation numbers. Greater the oxidation number on an atom, greater is its electronegativity. So out of the four, which one will be the most electronegative? HClO4, because chlorine is carrying what charge over there? आप ऐसे भी सोच सकते हो +7 on chlorine. इसका मतलब chlorine has given all the last 7 electrons that it has shared all the last 7 electrons with oxygen over here, and that's why it's highly electronegative, because it desperately wants electrons. So I repeat, greater the oxidation number on an atom, greater is the electronegativity. With me till here, people? Next. Now, let's talk about oxides. Oxides एक separate topic ही लेंगे हम in detail, but let's understand how electronegativity decides the characteristic of an oxide. Oxide का मतलब क्या होता है? Can anyone tell me what is an oxide? Compounds of or compounds with oxygen. These are called as oxides. Can someone tell me group 1? Group 1 का कोई, let's say I take sodium. तो sodium का एक oxide is excellent Na2O. Now when you take Na2O, you put Na2O in water. क्या बनता है 10th standard? Excellent NaOH. ये हमने 10th standard में पढ़ा है that oxides of group 1 elements are basic in nature. Have we learned something like this in lower standards? So let us understand why do we say that oxides of metals are basic in nature. अगर आप ग्रुप 1 के मेटल का ऑक्साइड लो या ग्रुप 2 के मेटल का ऑक्साइड लो, उसको पानी में डालो, it will produce NaOH. We know that NaOH is a base. Why is NaOH a base?
Hydroxyl ions.
Because it produces which ion? OH minus ions. Let's ask this question, why it is producing OH minus ions? Why isn't it producing H plus? Or for that matter, if I take, let's say something like SO3, sulfur trioxide. It's an oxide of sulfur. Sulfur के बहुत सारे ऑक्साइड्स होते हैं, SO2, SO3. मैंने SO3 ले लिया, SO2 भी ले सकते हैं. इस SO2 को कहाँ डाला अपन ने? पानी में. This will give us what? H2SO4. Yes or no? 10th standard contact process. We've done contact process in 10th standard for the production of sulfuric acid, but वो oleum से बनाया था, because directly sulfur के oxide को पानी में डालते हो तो it is highly exothermic. तो oleum बनाते, oleum से भी extract H2SO4. Anyways, coming back, SO3 को पानी में डाला, what do we get? Or can I say that oxides of non-metals are generally dash nature? Acidic oxide. And यहाँ पे oxides of metals are generally So what we need to understand is why is that NaOH is giving you OH. It again comes back to electronegativity. People, if I look at NaOH, Na, O and H. The electron, again you don't have to memorize the values. The electronegativity of oxygen is around 3.5. Pauling scale पे अगर हम देखें, so it is 3.5. The electronegativity of hydrogen on Pauling scale is around 2.2. And the electronegativity of sodium in Pauling scale is 0.98. For our convenience, let's take this as 1. हमारे लिए calculation easy हो जाता है. Okay. Now find the difference in electronegativity. I repeat, find the difference in electronegativity. Na and O के बीच का difference क्या है people electronegativity का? 3.5 minus 1 is 2.5. And what is the difference between oxygen and hydrogen का electronegativity? 1.3. Larger the difference in electronegativity, that bond is going to break. जिन दो atoms के बीच electronegativity difference सबसे ज़्यादा है, it is usually that bond that breaks. Did you people get that? I repeat, larger the difference in electronegativity, it is easier for that bond to break. And it's यहाँ पे सिर्फ electronegativity is not playing a part, even ionization enthalpy is playing a part. इसका मतलब क्या है? This bond will break. तो ये क्या बनने वाला है? Na is going to become Na plus, and this is going to become what people? OH minus, yes or no? In short, what has OH done? It has taken an electron from sodium. To remove one electron, that is similar to which property? Ionization energy. Obviously हमको पता है ionization energy of metals is the lowest. Getting that? So यहाँ पे there are two properties playing a part. एक है ionization energy, the other is electronegativity. Short में हम कैसे याद रखेंगे? Generally, if the difference in electronegativity is greater than 1.7. Now it's not a hard and fast rule कि 1.7 ही होना चाहिए. कभी कभी वो difference 1.7 होने पर भी आपको heat और वो सब supply करना पड़ता है किसी bond को break करने के लिए. I'll explain what that means later. But in general, if there is a large difference in electronegativity, then that bond breaks. समझ में आया मैं क्या बोला? I repeat, अगर electronegativity difference ज़्यादा है, वो bond break होगा. Let's take the second example. यहाँ पे हमारे पास क्या है people? H2SO4. H2SO4 लेंगे और एक और example ले लेंगे, एक acid का भी example ले लेंगे. We know that H2SO4 produces H plus. Why doesn't H2SO4 produce OH minus? H2SO4 का if I see the structure, this is H2SO4. Now over here, hydrogen and oxygen का electronegativity difference is greater than the electronegativity difference between oxygen and sulfur. इसीलिए ये bond break होता है. This breaks into H plus और यहाँ पे हमारे पास बचता है O minus and कभी कभी हम इसको लिखते हैं HSO. Something like this. Did you people get that? So larger in the difference in electronegativity between two atoms, that bond is going to break. समझा? Yes or no? Next, so ये oxides हो गया. Next we have ionic character. Now, just like when we were doing polarity, when we were discussing this, that even though this is a covalent bond, it has developed partial positive character and partial negative character. The polar, though it's a covalent bond, it is still developing charge, and development of charge is the nature of ionic bond. We have something called as ionic character. Ionic character means if the difference in electronegativity I repeat, if the difference in electronegativity between two bonding atoms is greater than 2.1, then the bond is ionic in nature. Let's take an example. Simple example लेते हैं. Let's take Na and F. हमने क्या approximate value लिया है for sodium का on Pauling scale 0.98 को हमने बोल दिया था चलो approximately 1 ले लेते हैं. And fluorine का is how much, people? So what is the difference in electronegativity? ऐसे लिखता हूँ delta En 4 minus 1, that is, so if the electronegativity difference is greater than 2.1, we will say that the bond is ionic. However, if the electronegativity difference is not greater than 2.1, the bond will still have ionic character. I repeat, if the electronegativity difference is not greater than 2.1, it will still have ionic character, or that is given by, or percentage ionic character, or the amount of ionic character is equal to 3.5 into difference in electronegativity the whole square plus 16 into the difference in electronegativity. So you can actually find even though a bond is covalent, what percentage, 20%, 30%, 40%, what percent of the bond is ionic in nature? Did you people get that? Okay, so I repeat, percentage ionic character, even though it is a covalent bond, it will have some amount of ionic character in it, which is given by this formula. Next. Now people, just sixth point is something, a concept which we haven't done yet. We will do it in a chapter called as chemical bonding and molecular structure. तो फिलहाल के लिए मैं सिर्फ उसको लिख के ले रहा हूँ. Greater the S character, greater is the electronegativity. फिलहाल के लिए इसको आप सिर्फ ऐसे ही कॉपी करके रखना. These are all orbitals S and P. I think आपको पता है already. चलो next. So greater the S character, greater will be the electronegativity. Next. Can someone give me the relation between metallic character and electronegativity? जितना ज्यादा electronegativity उतना ही कम. So I can say metallic character is inversely proportional to. And what will the relation be between non-metallic character? And electronegativity? It will be directly proportional. जितना ज्यादा electronegativity उतना ही ज्यादा non-metallic character. Next. Even 8th point is something which we haven't done. But I think thoda try and understand this if possible. Which molecule is this?
Water.
It is water H2O. ठीक है? We will study water का complete structure in the next chapter. But अभी के लिए ऐसे देखो, water is like an inverted V-shaped molecule. ठीक है? Water को हम बोलते हैं V-shaped या bent shaped. Water usually ऐसे हम बनाते, ऐसे लिखते थे ऐसे. But we write that for our convenience. But it is not a linear molecule. Water V-shaped होता है. और ये इसको हम बोलते हैं bond angle. And the bond angle in water is around 104 degrees. ठीक है? Now, similar to this structure, we have one more structure. So this is H2O and this is F2O. Okay. So, if you look, everything looks similar. ये भी bent दिखता है. दोनों का hybridization भी sp3 है. Now you won't understand this word hybridization. We do that in chemical bonding. तो वो word को फिलहाल के लिए इग्नोर करो. But ऐसे सोचो, दोनों दिखते सेम है, V shaped है, ऑक्सीजन ही है. But the bond angle here in F2O, ये bond angle है 103 degrees. So it is less as compared to water. So why is there a difference in bond angle? Basically, electronegativity also decides the shape and bond angle of molecules. Shape तो same है, but bond angle कैसे change हुआ? Let's try and understand this. People in oxygen and in hydrogen, who is more electronegative? So what happens is, ये वाला जो covalent bond है, the electrons of this bond is closer to oxygen as compared to hydrogen. Try and understand that. जो ये covalent bond के electrons है, ये वाला bond, this bond and ये bond. Since oxygen is more electronegative, the bonds are actually closer to oxygen as compared to hydrogen. Now since these bonds are closer, there is more repulsion between the electrons. And why is there repulsion between the two? Since the covalent bonds are closer. I repeat, since the covalent bonds are closer, there is more repulsion. With me till here? But, यहाँ पे आओ. Oxygen and fluorine में who's more electronegative? Fluorine is more electronegative. So the bonds are closer to. Since the bonds are closer to fluorine, the gap between them is bigger. So यहाँ पे there is less repulsion since the covalent bond electrons are far from each other. Did you people get that? Yes or no? Anyone did not understand this? I repeat, anyone who did not get that? And hence, if I have the same central atom, दोनों के केस में central atom कौन था people? Oxygen and the same central atom. Let's say I write it as B, same central atom. But जो side atoms attached है, they were different. एक केस में side atom कौन थे? Hydrogen, and in the second case, what were the side atoms? What were the side atoms? If the electronegativity of the side atoms increases, bond angle decreases. I repeat, when the electronegativity of the side atoms increases, bond angle decreases, provided the central atom remains the same. If you want that in theory तो मुझे बता देना, नहीं तो इतना लिखेंगे तो भी काफी है. I repeat, if the central atom is the same, the electronegativity of the side atom will decide bond angle. अगर side atoms की electronegativity बढ़ती है, bond angle कम होता है. I repeat, side atoms की electronegativity बढ़ेगी, bond angle will decrease. Did you people get that? बोलो रे, yes or no? ठीक है, that should suffix. Now people, for the 8th point, we have written one more example. If you observe the example here, these are halides of phosphorus. या हम क्या बोल सकते हैं इन्हें? These are trihalides of phosphorus. So we have phosphorus, trifluoride, trichloride, tribromide and triiodide. What are we observing? That the central atom is the same, phosphorus, phosphorus, phosphorus. And as the electronegativity of the side atoms decrease, we know that chlorine is more electronegative than fluorine. Pardon me, fluorine is more electronegative than chlorine, and so on and so forth. If you see, bond angle increases as the electronegativity of the side atoms decrease. ये ऊपर वाला ट्रेंड, बट यहाँ पे हमने उसको अप्लाई किया है टू ट्राई हलाइड्स ऑफ phosphorus. Now similarly, let's say what I've written on the board is hydrides. इनको हम बोलते हैं people compounds of or compounds with hydrogen. Yeah, these are the hydrides of, ठीक है, this is group 15 elements और यहाँ पे हमारे पास क्या है? Group 16 elements. Okay, I repeat, I have group 15 और group 16 elements के hydrides. NH3 को क्या बोलते हैं people? Ammonia. Everyone knows that. ठीक है, NH3 हमारा अमोनिया है. PH3 stands for phosphine. ठीक है, ASH3 is called as arsine and SbH3 is called as stibine. H2O is hydrogen oxide, yeah, water. Hydrogen sulfide, selenide, telluride. ठीक है, everyone got that? Switch the AC off, please. I repeat, water, sulfide, selenide and telluride. Now what we observe over here is, see, the side atoms are the same, H3, 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 H3. Okay. And यहाँ पे I have nitrogen, phosphorus, arsenic, antimony. As I know, if I go down the group, electronegativity decreases. So as the electronegativity of the side atoms decreases, I repeat, when the electronegativity of the side atoms decrease, bond angle decreases. Pardon me, not side atom, central atom. If the electronegativity of the central atom decreases, bond angle decreases. यहाँ पे हमने क्या पढ़ा था? If the electronegativity of the side atom decreases, bond angle increases. If the electronegativity of the central atom decreases, bond angle decreases. I'll write that point again. If the, I'm not writing pura electronegativity, I'm just writing En. If the electronegativity of the central atom decreases, bond angle decreases. And the same can be observed even over here. Central atom पे यहाँ पे oxygen, sulfur, selenium and tellurium. As I know, as I go down the group, the electronegativity decreases. As the electronegativity is decreasing, bond angle is also decreasing. Everyone got that? Yes or no, people? Chalo. Now similarly, let's say if I go from left to right matlab I have group 2 elements, carbon, nitrogen, oxygen and fluorine. So I'm going from left to right in a period. यहाँ पे हमारे पास है CH4, NH3, H2O and HF. Compounds with hydrogen. Central atom over here is carbon, nitrogen. There's no central atom as such in HF. Now what I observe is, as I go from left to right, what happens to electronegativity? As the electronegativity increases from left to right, acidic character increases. In short, which is the most acidic among the four? HF, followed by NH3 and then CH4. या HF के यहाँ पे हम क्या लिख सकते हैं people? Most acidic. So among the four, the most acidic is HF, the least acidic is CH4. As the electronegativity of the central atom is decreasing, acidic character, as the electronegativity of central atom is increasing, acidic character is also increasing. But if you go down the period, especially group 17 में, तो सबसे पहला HF के नीचे कौन आएगा? HCl. उसके बाद कौन आएगा? HBr. उसके बाद कौन आता है? If I look at these four, the most acidic is HI, then HBr, then HCl and then HF. Now here it's not related to electronegativity, but what it is related to is size. Let me explain that. I'll just write the key point over here. सबसे पहले HI over here is the, and यहाँ पे HF is, so if you compare HF with these, HF सबसे ज़्यादा acidic है. But if you compare them in the same period with HCl, HBr and HI, HI is the least acid, HF is the least acidic of the lot. Why? I'll explain. Though chemical bonding में ये better समझता है, we'll try and understand as much as possible. If I compare the size of hydrogen and iodine, there is a vast difference in the size. Iodine is an extremely large molecule. If I compare iodine का size with hydrogen, so दोनों के बीच में the atomic size difference is very large. थोड़ा बहुत अगर ट्राई करें तो बोर का फॉर्मूला क्या था? 0.529 into n square by z. Though we cannot apply that formula directly यहाँ पे, but एक hypothetically सोचो, इसके पास एक शेल है. What about iodine? 5. We know that radius is proportional to square of n. दोनों के साइज में 25 टाइम्स का ऑलमोस्ट डिफरेंस है. हाइड्रोजन प्रोबेबली ऐसा है कि ये आयोडीन है. Do you think can they really form a bond? No, they can't. Because bond formation is very poor. Compared to H and F, ये थोड़ा H पकड़ लो और ये थोड़ा F का p ऑर्बिटल है. ठीक है, साइज डिफरेंस ऑलमोस्ट मतलब मैनेजेबल है. यहाँ पे साइज डिफरेंस मैनेजेबल नहीं है. अगर ऐसा डिफरेंस इन साइज रहेगा, ऑब्वियसली यू कैन नॉट रियली फॉर्म अ बॉन्ड. How you will get a summarize like your size का trying to have a month baby old के कपड़े. Almost actually something like that. ठीक है? So due to the difference in size, it is really easy to break the bond between H and I. That bond breaks quickly, produces H plus, which is acidic. As compared to the bond between H and F is very strong. So remember, stronger the bond, lesser the acidity, weaker the bond. तो इसका bond strength ज़्यादा है. इनको bond strength में compare करना है तो this has the highest bond strength and HI has the weakest bond strength. Did you people get that? Yes or no? This completes electronegativity. We are still left with something called as common terms and oxides. Okay, that probably should take us one more lecture and we will complete the chapter next class. Okay.